And in the last session, I have discussed about the Ohm's law, the definition of the Ohm's law, and on which factor the resistance depends. Everything we have seen in the last session, and in the last session also we have discussed about the specific resistance or resistivity, which is denoted by the letter rho, and the units of specific resistance is ohm meter. Clear? So now we will discuss about the specific resistance. Specific resistance, and this specific resistance is denoted by the letter rho. So this specific resistance is denoted by the letter rho. Now what we do is, we'll take the relation between the current and drift velocity. Already in the last class also we had discussed about this relation between. We'll see how this rho will have an impact on the drift velocity. Clear? And how this will have an impact on the temperature. Everything we'll see here. The relation between the current and drift velocity. Vd is equal to I by NEA. From this, I is equal to what we can write? NEA Vd. As charges here are electrons, so I will take I is equal to minus NEA Vd. Clear? Up to here already we have studied. Clear? Now Vd is equal to what can I write? Vd is equal to minus E, capital E by tau by m. So Vd is equal to, already this is also we have discussed, minus E into E, this is E, capital E, tau by m. We'll substitute this drift velocity value in the current. We'll substitute in the current. We'll see that. So I'll get I is equal to minus NEA into what is the value of Vd? Minus E into capital E, electric field, into tau, relaxation time, by m. Clear? Minus into minus is plus. Then n into E is E square. Like the remaining terms of A, E, next tau by m. Clear? From this what can we write? N into E square, A into tau by m. Then E. What is the value of E? In the Ohm's law already have said E is equal to V by L. So I'll substitute this also here. You will get N into E square, A into tau by m into V by L. V by L. We know the formula. R is equal to V by I. I is equal to, what is the formula? I is equal to V by R. Next, V is equal to IR. V is equal to IR. So see once. So still to solve that equation, N is equal to E square tau A by M into V by L. From this what can I write? From this I will take the V to the right hand side. Then V is equal to what will happen? ML. This in the denominator part ML, it will go to the numerator part ML by N E square A tau into I. So how this looks? V is equal to IR. This is R. This is I. So I can write R is equal to, from here. So this is in the form like this, V is equal to IR. So R is equal to, what can I write? ML by N E square A into tau. This is one of the formula. So R is equal to what I have written? M into L by N into E square A tau. or m by n e square tau into L by A. Yes. Now, so I'll write one detailedly again. R is equal to, what I can write? M by n e square tau into L by A. L by A. Now, what is the formula for resistance? R is equal to rho L by A. Yes or not? L by A. So, this is the formula for rho I can write. So, from this I can write rho is equal to M by N E square tau. N, rho is equal to M by N E square tau. Clear? So, by taking the relation between the current and drift velocity, so we have calculated the rho value also from the drift velocity and the current. Now, then what is M? We'll see each and everything. So, every formula is very, very important. If you know one formula, if you know this formula relation and if you know this relation, you can derive all the relations. Clear? Yes. Now, what is M? You observe the equations, formulas. M is mass of electron. M is mass of electron. E is charge of electron. E is charge of electron. Then what is small n? Number of free electrons in unit volume. Number of free electrons in unit volume. So, have a glance over this. So, rho is equal to M by N square E into tau. Clear? Next. So, M means where M is equal to mass of electrons. E is equal to charge of electron. What is charge of electrons? 1.6 into 10 power minus 19 charge of electrons. Then N. N is number of free electrons. Number of free electrons per unit volume. Per unit volume. Clear? And we know the formula just now we had derived. Rho is equal to, see here, rho is equal to M by N square E into tau. M by N into E square tau. So, my question is that here, if number of free electrons are increasing, what happens to the resistivity or specific resistance? So, if number of electrons are increasing, definitely the resistivity will decrease. Definitely the resistivity will decrease. Yes or not? Because inversely proportional relation is there. If number of electrons increases, resistivity decreases. If number of electrons are increases, the resistivity will decrease. If number of electrons are decreasing, then the resistivity will increase. If resistivity decreases, what happens to resistance? If resistivity decreases, what happens to resistance? Rho is equal to, or R is equal to rho L by A. From this, rho is equal to R A by L. If resistivity decreases, what happens to resistance also will decrease. Resistance will decrease. Remember, if number of free electrons are increasing per unit volume, the specific resistance will decrease. If specific resistance decreases, then the resistance also decreasing. The resistance is also decreasing. So here this tau depends upon the temperature. This tau depends upon the temperature. Why? Because due to the heat generation only, the movement of electrons is happening in a conductor. Due to heat generation, due to thermal generation, due to heat producing, due to heat generation only, the flow of electrons is happening in a conductor. Yes or not? If I am taking a very thin wire, the collisions will occur. and the collisions will occur if I take a thin wire. Clear? So one more point I can write here is tau depends upon temperature. So tau depends upon the temperature, and if number of electrons are increasing, resistivity will decrease. If resistivity decreases, resistance also will decrease. Now if tau decreases, what happens to temperature? If tau decreases, temperature will increase. If temperature increases, there will be movement of flow of electrons, then resistance will increase. If resistance increases, resistivity also will increase. If tau decreases, temperature increases, resistance will increase, and resistivity also increases. Suppose I have taken silver and copper. In general, silver will have more free electrons than copper. In silver, we have the more free electrons than the copper. Clear? Next we'll do problems. We'll do 2 problems. So this was about the specific resistance with respect to the current and the drift velocity parameters. If one factor increases, what happens to the other factor? This is very important. You can expect a theoretical question based on this concept. You can expect a theoretical concept or a problematic also. So we'll do one problem. Write the question. 2 wires, one of copper and the other of magnanite. Wires having same resistance and equal thickness which wire is longer? Very interesting question. If you know the concept of the resistance and the resistance depends on which parameter, you can solve these questions. Now in the question they have given 2 wires, one of copper and the other of the magnanite wires having the same resistance and equal thickness. Which wire is longer? Read the question once again, you people. 2 wires, one of the copper and the other of magnanite wires having same resistance and equal thickness. Which wire is longer? So alloy you will study in the materials also. Magnanite is a alloy material. What is the alloy? First read the question carefully. So 2 wires they have given. One is copper and the other is magnanite wires having the same resistance, very important, and equal thickness. Same resistance and equal thickness. Area is same and resistance is also same for the 2 materials. Now magnanite wire is a alloy. Alloy means mixing of 2 or more metals is alloy. Yes or not? Yes. Mixing of 2 or more metals. Now, generally the resistivity for magnanite wire will be more than copper. This is very important. The resistivity will be more for the magnanite wire than the copper. This is the first condition. Second is resistance are same, which means R copper is equal to R magnanite. R copper is equal to R magnanite. And I know the formula of the resistance also. I know the formula for the resistance. R is equal to rho L by A. As resistance are same, no need to take, it will be equal to 1. So from this, what can I write? And area is also same because equal thickness. So I'll write rho copper is equal to, one second. So from this I can write rho copper into L copper by A is equal to L rho magninine into L wire by A. As area is same, A you get cancelled. So from this I'll get rho copper by what? Rho magninine. Yes or not? Rho copper by rho magninine is equal to what we can write? Rho copper by rho magninine. Rho copper by rho magninine is equal to, or we can write other way. Why? Because already I know magninine wire is greater than copper wire. I'll write in that way, simple. L copper by L magninine is equal to rho magninine by rho copper. Directly we can write rho magninine is greater than rho copper. Yes or not? Yes. So I'll write here rho magninine by rho, this is L, rho copper. And I know rho magninine is greater than rho copper. So from this I can write L copper by L magninine is greater than 1. Is greater value, yes or not, from this equation, because the resistivity for the magninine value will be more. So it will be greater than 1. From this I can write L copper is greater than L magninine wire. L. So see, rho is denoted by the letter like this. This is L, small l. Clear? So which wire is longer? Copper wire or magninine wire? Copper wire is more longer. So the copper wire is more longer. You can expect questions like this also. The copper wire will be more longer. Clear? Just check, have a glance over the problem. You people just pause the video and write the notes, whatever we have given, whatever I have given, whatever I have written on the board. So because I already said, practice makes man perfect. Practice makes man perfect. Because always learning should be enjoyable. Learning should be enjoyable and it should be always stress-free. Because learning builds the confidence building. Learning builds the confidence building and it also builds the time management also. It also builds the time management also. Because in the competitive exam, confidence building is very important and stress-free is also very important. How can you achieve all these things? You can achieve all these things by only one way, that is learning, practicing, implementing in the exam. Learning, practicing, implementing. That's all. Clear? So we'll do one more problem also. Write the question. When 5 volts potential difference, when 5 volts potential difference is applied across a wire of length 0.1 meter, the drift speed of electrons. Electrons is 2.5 2.5 into 10 power minus 4 meter per second. So the units for drift velocity is meter per second. The unit for current density is ampere per meter square. Units are very important. Ampere per meter square. Full stop. If the electron density in the wire is 8 into 10 power 28 meter cube. Calculate the resistivity. Calculate the resistivity of the material of the wire. So we'll solve this question. When 5 volts potential applied across a wire of length 0.1 meters, the drift speed of electrons is 2.5 into 10 power minus 4 meter per second. If the electron density of the wire is 8 into 10 power 28, calculate the resistivity of the material. So in the question we have to calculate the resistivity. Yes or not? Yes. Just read the question once, you people. Understand the question? How can we find the resistivity of the material? How can we find? Yes. So in the question, always write the given data. When 5 volts potential difference is applied across a wire of a length they have given, they have taken a wire, that wire is having 5 volts potential difference and that wire length is 0.1 meter. A wire I have taken, that wire potential difference is 5 volts and the length is 0.1 meter, and the velocity, speed of electrons is, see, from this end to this end, the velocity is drift velocity, which is Vd is equal to how much? 2.5 into 10 power minus 4 meter per second. Next, if the electron density in the wire is 8 into 10 power 28, electron density, N is equal to how much? 8 into 10 power 28. So we have to calculate the resistivity. Resistivity is denoted by the letter rho. How? I know the formula, only one is R is equal to rho L by A. So one important thing is that application of the formula is very important here. Not only here, in any subject. Application, if you know the formula, that is not enough. Application is very important. Here, I know only the formula R is equal to rho L by A. But in the given data, they have not mentioned the area. They have not given the resistance. And length is given. But I have to calculate the rho. Is it possible? So, if you know the application, you can do it. So, with respect to drift velocity, we'll see. What is the formula for current? The relation between the current and the drift velocity? Vd is equal to I by N into E into A. Yes, yes or not? Yes. So from this, I is equal to, what can we write? N into E into A into Vd. So I know one more formula, V is equal to IR. Ohm's law, V is directly proportional to current. From this, I is equal to V by R. So V by R, I'll substitute in the place of I is V by R is equal to N into E into A into Vd. Next we do is V is equal to, I'll take this R to this side, N into E into A into Vd into R. What is the formula for R? Rho L by A. So V is equal to N into E into A into Vd into rho L by A. From this formula, bring the rho outside. So how much will be? So rho is equal to AV by N into E into A into V D into L. Clear? Now we'll substitute all the values. Yes or not? Sorry, here A and A will get cancelled. Yes or not? A and A will get cancelled. So no need to write A here. So now we'll substitute the values. What is the V value? Potential difference is 5 volts. So 5 by number of electrons are 8 into 10 power 28. Clear? Next, charge of electrons is 1.6 into 10 power minus 19. So definitely you have to learn the charge for electron, proton and neutron also. What is the charge for neutron? 0, my dear, 0, that is. Clear? Vd is how much drift velocity? 2.5 into 10 power minus 4 into what is L? 0.1. You have to solve all these. Clear? 28 minus 4 and this is 0.1. It will go to the numerator 10. So I'll get 5 by 1.6 into 8. So we'll do by the calculator and we'll check the answer. So in this way you have to do the problem. The problem is very easy if you know the application. If you don't know the application, it is very difficult. You know the process. If you know one formula, that is not enough. The application you have to know. Into, you please check the answer. 3.2. 1 point. So you'll get here. Just I have given this much calculation, they will not give. Why I have given this type of problem is you have to know how to apply the formulas. So in that purpose I have given the problem. Clear? So 1.56 into so you will get 10 power minus 5. What is the unit? Ohm per meter. 28, 19 here, you will get plus 9. 9 minus 4 is 5. 9 minus 4 is 5. So, in the denominator, you will have 10 power minus 10 power 5. If it goes to the numerator, it will become 10 power minus 5. Clear? So, the units for resistivity is ohm meter. Clear? We'll do one more problem also. See, everything we are doing in application oriented. Application, that is very important. Where we have to apply, that is more important. Yes or not? Yes. Application is the most important. Okay. We'll do one more problem also. Okay, later we'll do it later. After one more. After one more concept, we'll do the problem. So check this. Application. See, this much calculation they will not give, but application is more important for you. Next, we'll see the variation of resistance with the temperature. Variation of resistance with the temperature. If temperature increases, what happens to resistance? So we'll derive a formula for this. We'll see that. Clear? So next we'll see variations of resistance with temperature. So if I take a conductor of a cross-section area, and it will have some finite length L. So I'll take a conductor, not bus conductor. You people are very crazy. Of some cross section of some cross section. At the same time, it will have some length. It will have some finite length. So, if in the first case, if the resistance increases, what happens to temperature also will? Temperature also will increase. If I have taken R1 resistance, then it will be T1. The first case, if R1 resistance they have taken, the temperature will be T1. If R1 resistance I have taken, the temperature will be T1. Then the resistivity will be ρ1. Now once again, what I have done, I have heated the wire. I have applied a heat to the wire. Again I have heated the wire. Then what happens? Definitely the temperature increases, the resistance also will increase, and the resistivity also will increase. Yes or not, in the two conditions. Now, there is some change in resistance, some change in temperature, and some change in resistivity. Yes or not? In both the cases we observe, there is some change in resistance, temperature, and the resistivity. So, how can we write this change in resistance, temperature, and the resistivity? By R2 minus R1, R2 minus R1, and T2 minus T1, and ρ2 minus ρ1. So, can we write like this? So, from these, can I write R2 minus R1 is directly proportional to T2 minus T1. R2 minus R1 is directly proportional to T2 minus 1. There is happening some change in temperature because of heating the wire, and then there is happening some change in resistance also. For example, if I take R1 as 10 ohms, initially I have taken 10 ohms. In the second time, I have heated the wire. For 10% I have heated the wire. Then what is the new value of resistance? For 10 ohms, what is the 10%? 1, which means 11 ohms. 11 ohms. If suppose I have taken the large resistance like 100 ohms. If I have taken a 100 ohms resistance and I have increased it to 10% of the, which means I have given 10% of the heat to the wire. Then what happens? It will become how much? 10%. Yes or not? 110 ohms. Clear? So it has been increased by some percent of resistance. So this we can write with respect to some mathematical expression as R2 minus R1 is directly proportional to R1. R2 minus R1 is directly proportional to R1. So now what we do, we combine these equations. I can write R2 minus R1 from equation 1 and equation 2. I can write R2 minus R1 is equal to R1 into alpha plus T2 minus. So by combining the both equations, what can I write? R2 minus R1 is equal to R2 minus R1 is equal to R1 into T2 minus T1. R1 into T2 minus T1. So, I'll write in simple way. First is R2 minus R1 is directly proportional to R1 and T2 minus T1. This is the first one. Now, I'll remove this proportionality. Then I'll get R2 minus R1 is equal to alpha into R1 into T2 minus T1. Yes or not? So I remove the proportionality, then I'll get R2 minus R1 is equal to alpha into R1 into T2 minus T1. What does the alpha here? Alpha is the temperature coefficient of resistivity. Alpha is the temperature coefficient of resistivity. Alpha will be different for different materials. Alpha will be different from different materials. From this, we'll find alpha is equal to R2 minus R1 by R1 into T2 minus T1. Very important formula for solving the numericals. So alpha is temperature coefficient of resistivity, very important. And one more thing, note is that alpha will be different for different materials. So from this, alpha is equal to R2 minus R1 by R1 into T2 minus T1. So alpha is known as temperature coefficient of resistivity, and alpha will be different for different materials. Clear? Yes. So for now what we do is, we will derive the relation for R2 also. We derive a relation for R2 also. We'll see that. So I know R2 minus R1 is equal to, see here, this one, R2 minus R1 is equal to alpha into R1 into T2 minus T1. From this, what I can write, R2 is equal to alpha into R1 into T2 minus T1 plus minus R1 will become plus R1. So from this, what will become? So R1 into